Hello everyone, welcome to EPT classes. Today we will discuss first chapter number systems of standard 9. Its example we will discuss. Okay, let's start. Example number 5. That is, find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. How to find the decimal expansion? So here first one is 10 by 3. So let's write the number 10 by 3. 10 is the numerator, 3 is the denominator. So what we'll do? First divide that one. 10, okay, divided by 3. Then you know that one. 3 is 9. Then it will subtract 10 minus 9 equal to 1. If 1 is the number, here is 3, we can divide directly, so we must do the decimal point. If we do here decimal point, then 1 0 should be written here. Now it becomes 10. 3 is again, that is equal to 9. Then it will subtract 10 minus 9 again 1. If already you have used the decimal expansion, that means this decimal, then again 0 will come here. Then 3 is here 9. Again that is 1. So it is repeating. That means 3.33333 like that it will repeat it. Repeating means that's remainder should not become 0. Remainder is always 1 will come. But it is repeating means that is a rational number. So 10 by 3 decimal expansion. We can write here 10 by 3. The decimal expansion is 3.333. Otherwise, we can write 3.3 is repeating. So 3 is back. Over. So next, second one is 7 by 8. Okay, 7 is the numerator, 8 is the denominator. So 7 divided by 8. 8 is the greatest number than 7. 8 is greater than 7. So first of all, you must write the decimal point. If you write the decimal point, 0 we can write here. So that means decimal point you can write. Before that you can write 0. That's 7. Then if you put here decimal point, then 0 will come here. Now 8 6 is 48, 8 7 is 56, 8 8 is 64, 8 9 is 72. 72 is greater than 70. So we will put here 8 8 is 64. So 70 minus 64, the result is now 6. 7 minus 64, the result is 6. So again 6 came. We already discussed the first one, 10 by 3 when we discuss. One decimal point must be there. Then 0 0 should be written here. That means if here is the decimal point, then 0 also you can write here. 8 5 is 40, 8 6 is 48, 8 7 is 56. Because 88 is 64, that is greater than 60. So 8 7 is 56. To subtract 60 minus 56, the result is 4. Then the same thing also 0 will come. Now 8 5 is 40. 8 5 is 40. 40 minus 40, the result is 0. Now remainder becomes 0. Remainder becomes 0 means he can write 7 by 8. The decimal form is 0.875. You know that one? That is 0.875. That is the terminating decimal. Actually, this one is known as terminating decimal. Because here remainder becomes 0. Remainder becomes 0. So these are known as terminating decimals. This one, second one completed 7 by 8. Next we will discuss 1 by 7. Let's see. Last one, third number is 1 by 7. 1 by 7. Okay. The same thing also. 1 is the numerator. So you should write 1 here. And 7 is the denominator. You can write here. 7 is greater than 1. So 0 point decimal. You can write. If you write decimal, 0 should be written here. 7 1 0. What? 7. Then 10 minus 7, it will subtract. Again 3. Next, if there is decimal point, I told you already that 0 again will come. So 7 4 0 28. Like that. 30 minus 28, the result is 2. If the decimal point is there, then it will become 20. 7 2 0 40. Then you subtract 20 minus 14, that is also 6. Then it will become 60. 7 7 0 49. 7 8 0 56. 7 9 0 63. So 63 is greater, so you can put 7 8 0 56. Now you will subtract and write it here. 60 minus 56, the result is 4. Then if there is decimal, again you can write 0. 7 4 0 28. 7 5 0 35. So 7 6 0 42, that is greater. So you can write 7 5 0 35. 40 minus 35, the result is 5. Then if decimal point is there, then 50 you can write, because 0 should be written here. 7 7 0 49. So 50 minus 49, 1. Okay. So 1 if came, that means again 0. You can write here. 7 1 7. 10 minus 7, the result is 3. Result is what? 3. Now look at here. 0.142857. After that again 1 came. So again 142857. Like that it will repeat it. It will repeat it. So you can write 1 by 7 is equal to 0.142857. Again 1428 or you can write, if it is repetitive, you can write 0.142857. It's back. It's back. So 1 by 7, that is also after 6 decimal places. After decimal, this 6 decimal, 1 2 3 4 5 6. Again it is repetitive. If repetitive, that is known as also non-terminating, but repetitive. But what? Repetitive. For non-terminating, repetitive means it is also rational. So what we observe here? If a rational number, its remainder becomes 0. Here, remainder becomes 0. That is also said to be rational number because it is terminating decimal. Because that value is 7 by 8 equal to 0.875. That is terminating decimal. Here, it is also non-terminating. Why non-terminating? Because it is again repeating. The remainder should not become 0. But here, it is non-terminating but repeating. That is also a property of a rational number. So, rational number may be terminating, or if it is not terminating but repeating, then it is said to be rational number. Okay? Next, example 6 we will discuss. Okay? Now, example 6. Example 6 is so that 3.142678 is a rational number. So 3.142678, how to write that one in rational number? Just tell me. Rational number means what? Rational number we already discussed. That can be written in the form of p value. So 3.142678 we can write it in the form of 3.142678 divided by Then after decimal point, what is there? 1, 4, 2, 6, 7, 8. How many numbers are there? 1, 2, 3, 4, 5, 6. So we can write here 3, 1, 4, 2, 6, 7, 8 divided by 1. 1, 2, 3, 4, 5, 6 numbers are there. 6 zeros you can write. Like that. 2.3. Can we write in the form of P by Q? Yes, obviously. 2.3 means 2, 3. After point means after decimal, one digit is there. You can write 1. One digit means 1 0 you can write. If 3.394, you can write 3394 divided by 1. After decimal, 3 digits are there. 3 0 you can write. So now let's see 3.142678. You can write 3142678 divided by 1. It's 6 zeros. That means already written in the form of P. So it is a rational number. It is a rational. Now we'll discuss some properties of rational and irrational number. So what are the properties? Let's see. The properties are, wait for 1 minute. So one side I am writing rational number, another side is irrational number. So rational means maybe it is terminating. First one is what? It is terminating. That means the remainder becomes 0. Terminating means remainder becomes 0. Remainder becomes 0. And another one is also, if that is non-terminating, that means that is not terminating, it will be non-terminating. Non-terminating. But whatever the value will come in quotient, that value must be repeating. So two properties are terminating, that means remainder becomes 0. So suppose I am writing 2 by 3. 2 by 3 is a number. You can divide 3, then 0 point, decimal means 1 0 will come. 3 6 18, again 2 will come, again decimal means 0 will come, again 3 6 18, again 2 will come, then decimal, then 3 6 18, like that it will repeat it. Repeated means 0.66666 like that. It is non-terminating. It did not end because there is 20 minus 18 equal to 2. So remainder is not equal to 0. So if remainder is not equal to 0, it is non-terminating. But why we say this one is a rational number? Because non-terminating, but there is after decimal 66666, that same value here is coming. That means it is repeated. So non-terminating but repeated, that is also rational number. So rational number two properties, terminating and non-terminating repeated. Now think about irrational number. Irrational number is what? What is irrational number? Irrational number means irrational number non-terminating and non-repeating. Non-terminating and non-repeating. That is said to be irrational number. Like pi. Pi can say we are writing 22 by 7. That is the approximate value. That is not equal to pi value. Actually the value is 3.14 something is there. So that is non-terminating and non-repeating. It should not be repeated. So that is pi is an irrational number. Like that you can say root 2. Root 2 is also non-terminating and non-repeating. How? Look at here. I am writing root 2. Suppose root 2. Any other value, just tell me. Suppose 16 is root over. How to find root over of 16? Root over 16, that means 16 divided by, that is the one number 4. We already discussed in our previous video. You can see 4 4 jam 16. That is 0. So 4 is root over 16. The value is 4. Value is 4. Like the root 2. How to find root 2? Root 2, you can write 2 like this. Which number you can write here? That same number must be there. So if I write here 2, then here must be 2. So 2 2 is equal to 4. That is greater than 2. So we cannot write 2. So we must write any number. That number 1 1 j. Suppose I am writing 1 1 j 1. Yes. 2 minus 1, the result is 1. Again, we already discussed in our previous video that 1 should be added. 1 plus 1 equal to 2. Then decimal points we have to write. If decimal point will write, then double 0 at a time will come. Here, double 0, because root over we are finding, that means double 0 will come. Now, here, if I am writing 4, there must be 4. 24 4 is 96. So, again 4. Then that 4 will add here. 24 plus 4, that is 28. 4 already, that means double 0. So that 1 you can write here, another 1 also you can write. So 281. Again it will subtract, then the result will be 119. Okay. So that one again add here, that will be 282. So again the numbers, any other number will come. So it is non-terminating. It should not be terminated. It will go. Okay. It should not be terminated. And non-repeating also. 1.41 other number, any other number will come. So it is said to be irrational number. Okay. This one our 5 and 6 examples.